Hello guys, today we are going to discuss about the topic K-means algorithm. So this is a very good algorithm for doing the clustering process, and this is one of the traditional approach for doing the clustering applications. Two methods are there basically, that is the K-means and K-medoids. Two algorithms are there. We can call it like centroid based technique also. So this K-means algorithm, that is completely based upon the input parameter K here, and based upon this K value only the partitions can be made here based upon the n objects into the set of clusters here. And we have to see that while doing the clustering also, the intercluster similarity should be high, and the intercluster similarity should be low here. Always see that the intercluster similarity should be high and the intercluster similarity should be low here. That means within the cluster, if any data points are there, all these data points, it should be similar which are in the within the cluster. And if any data points are there which are outside the cluster, again they should have the less similarity between these two clusters. If you compare here, again they should have the very low similarity. And the cluster similarity, it is measured with regard to the mean value of the objects in a cluster. Mean value of the objects, completely this K-means algorithm, it depends upon the mean value of the given data points here, and which can be viewed. That means we are going to call it like a cluster centroid or center of gravity. We will call it like this. And how this K-means algorithm will work here means, let's see, let's go for the algorithm first. Algorithm, K-means algorithm, it is used for the partitioning where cluster center is represented by the main value of the objects in the cluster. So what is my input value here? K is my input value here, where it will decides how many number of clusters has to be formed. And D is nothing but the data set containing the n number of objects. And what is my output? Finally, I'm going to get the clusters here. How many number of clusters are there? That clusters will I'm going to get as the output here. And what is the method here? That is first step is arbitrarily I have to choose the K objects from the D as the initial cluster centers here. And the next steps I have to repeat it again. That is I have to reassign each object to the cluster to which object is the most similar based upon the mean value of the objects in the cluster. We are going to assign the objects to the most nearest cluster. And update the cluster means, next we have to find out the new cluster means and the new cluster values here. Calculate the mean value of the objects for each of these clusters here based upon the new mean values. Again we have to calculate the new mean values, and for these mean values, again for the rest of the data objects I have to calculate the distance values, and then I have to assign the cluster assignments. So these two steps will be repeated until there is no change in each and every iteration here. So this is the algorithm of the K-means. And let's see the example of the clustering exercise here. So I have taken the X values and the Y values. Both are the two different sets of data points here. So if we are assigning these data points in the form of X and Y coordinates, means these are the data points we have assigned here. And I have taken this point as one random cluster center point or the seed point. This is my one more seed point, and this is the another seed point. For these seed points, now I have to calculate for each and every data point. I have to calculate the distance for this point, and again for this point, and again for this point. So I will see based upon the lesser distance I am going to assign to that cluster back again. So like that clustering can be done. So let's see one exercise here, that is if you take this particular exercise, I have taken randomly 1, 5, 4, 1 and 8, 4 as my cluster seed points. 3 seed points I have taken here, and I have calculated the Euclidean distance here. How the Euclidean distance can be calculated here? So D is equal to x2 minus x1 whole square plus y2 minus y1 whole square here. This is my distance measures here, and C1 is equal to centroid C1 is equal to 2.66. That means after calculating the distance, now check for which seed point your Euclidean distance is very less. If you observe here, for the C1 value Euclidean distance is very less, so I have assigned to the cluster 1. In the same way, if you take the 2, 6, again we have assigned for the cluster 1. And if you take the 5, 6, again we have assigned to the cluster 3. And if you take 4, 7, we have assigned for the cluster 1. And for the 8 comma 3 again we have assigned for the cluster 3, and for the 6 comma 6 I have assigned for the cluster 1, and for the 5 comma 2 I have assigned it for the cluster 2, and for the 5 comma 7 cluster 3 like sign, and likewise and so on we will assign all the clusters to the nearest distance measures. So somehow we have assigned all these data points like this here to the nearest data points or the seed points only. We are going to assign these data points to the clusters, to the respective clusters. So next I have found that again for the 6 comma 3 in the iteration 1 we have assigned to the cluster 3. We have assigned to the cluster 3, but in the iteration 2 if you observe here it has been assigned to the cluster 2 here. So there is a change in the data points here. So previously it is cluster 3, but now we have assigned it to the cluster 2. So here again my new mean values will be changed here. So these are my new mean values. Now in the next iteration for these mean values only I have to calculate the distance values here. So for these new mean values again I have calculated the distance measures, that means based upon the Euclidean distance measure, and we have assigned the clusters here again back. But if you observe clearly for the point 8 comma 3 what is my cluster number here, I have taken that C2 as my cluster number here, and as there is a changes in the clusters again I am going to calculate the new mean values or the new centroid values here. So after calculating the new mean values or the centroid values, next we are going to find out again the distance for these new mean values and the new medoids, new mean values, sorry. And for these clusters I have assigned, and I got the again the new mean values like 2 comma 5. Why? Because there is a change in the cluster assignment for the 4 comma 7 in the third iteration, and the third iteration we have assigned to the cluster 1, but in the fourth iteration we have assigned to the cluster 3 here. So these are my new mean values. For these mean values only we are going to calculate the distance for the given data points, and we will assign the cluster centers. And next if you take the iteration 5 here, there is no change in the clusters compared to the cluster 4 and the cluster 5. That means there are no movement of the data points here. So these are my final clusters and these are my final seed points. These are my fixed seed points and these are my final cluster assignments. So that's how based upon this k-means only we have assigned the clusters like this. I have taken the k value as 3 and I got the 3 clusters here. This is the example of the k-means algorithm. And what are the disadvantages of the k-means algorithm? Means k-means it will works very well for all the numeric values or like numerical measures, but it will not work very well for the categorical attributes, and we have to specify the k value in advance. We have to specify the k value in advance, and it can be seen sometimes as a disadvantage also. And the k-means method, it will not be useful for discovering the clusters which are in the arbitrary shapes like S shape or W shape or any arbitrary shaped clusters we can't find out with the help of the k-means algorithm. And one more important point is it is very noise and sensitive to the outlier and the data points also. So this is one of the important thing of the k-means algorithm. So, and one more important point is this is very important from the university examination point of view. Whenever they are asking this k-means algorithm, don't simply write the k-means algorithm only. You try to explain the k-means algorithm with the help of some few data points and with the help of some example. Then only you are going to get the good marks. So that's all for today. Thank you guys. Thank you for watching this video.